Hello everyone, and welcome to Smooth-On's Making Things with Milo live presentation on cavity pours, matrix molds, and blanket molds. Now, my name is Milo, and I'm your host today. I'm also one of the material specialists here at Smooth-On. Today I'm joined by Jason and Alex, my co-workers. They will be handling the controls and the chat. And speaking of the chat, please, if you feel like you have questions that you want to ask, use the chat feature to ask anything about today's topic, Smooth-On materials, molding techniques, and we will try our best to answer it live on air. Now, if we don't get to your question, please feel free to submit a tech ticket using the link below for the customer support page. You're going to find a link that's going to allow you to contact us and attach some pictures to a ticket and ask any questions you may have about a molding process or our materials. Now, what we'll be learning today, we're going to be learning about advantages of making a cavity pour versus other mold making methods. We're going to be analyzing our original model that we chose to make a mold of. We'll be choosing materials for the mold and the support shell, and we're going to be talking about materials in general for the application. We're going to be determining the separation lines on our model, as well as claying up the model and talking about clays that are used for this application. We'll show you some placement of air vents, pour spouts, flow channels, and keys on your buildup. And we're going to show you a step-by-step creation of a support shell and then pour a silicone mold into it. Now, the materials we're going to be covering today are the MoldStar 30, which is a platinum silicone. That's going to be our molding material. The Dual Matrix Neo, that is our support shell product. It's a polymer modified gypsum system that we're using, as well as some additives for the Dual Matrix Neo, the Matrix Accelerator, Matrix Thickener, Matrix Chopped Glass are all going to be used or showing, as well as the Sonite Wax, which is going to be used as a sealer and a release agent. So, now, when we start talking about cavity pour molds, we want to be scrolling down the list, and we're going to be starting talking about terminology about these molds, where the actual word comes from, cavity pour, or matrix mold, or blanket mold, and what it stands for. So the molding method or procedure that creates a hollow space that we're going to be pouring a liquid molding product into. Basically, that sums up a cavity pour mold. So we're going to focus on making a support shell around the model, and then we're going to be pouring silicone into that cavity that we created to create the silicone mold. The name itself comes from the molding procedure. It is used in different industries by different makers, and that's why it has several different names that it's referred to. So cavity pour, matrix mold, blanket mold. Again, that's all sums up the same mold design. It's just because it's used in different industries, different people will call it different names. Now, if you guys have questions at any time, please feel free to just voice them out, and Jason is going to let me know there's a question coming in, and we can answer that as we go along. Now, let's talk about some of the advantages and why we would make a cavity pour mold. Now, as always, you want to start at the beginning. Sorry, let's try that again. You want to start at the finish of your project. You want to think about what you're trying to achieve in the project, what is important to you about that project, and that's going to determine how you're going to make the mold, what mold type you're going to make, what mold materials you're going to be using. Now, the advantage of making a cavity pour mold over something like a block mold is a huge material savings in silicone. So a block mold will usually eat up a lot of material, which results in a lot of cost, whereby a cavity pour mold is much smaller, and the focus is on making the mold much smaller in order to conserve material. Now, the mold itself, if you pour it in one shot, where you mix up a batch of rubber and pour one single shot, itself is going to be much stronger, much better than if you're applying multiple layers doing a brush-on mold. That's not to say that you can't make a brush-on mold, it's just there's different ways of doing that. And that's why we're going to be focusing on the same model that we had in the last live presentation, making a brush-on mold, so that you guys can see that there's different possibilities of the same model, that you can make a different type of mold off the same model. Now, what are some of the other benefits of making a cavity pour mold? Well, if you run a production shop and you need to cast a lot of repetitive pieces that are the same, you're gonna wanna make a cavity pour mold because your silicone itself, the silicone mold, at some point will get spent. The rubber itself will wear out and it's going to show signs of wear on the rubber on the inside. Now, in order not to recreate the entire mold, you can then go to use the setup that you have of the support shell, set it up back around your model, and pour a new mold into that support shell, not having to recreate a support shell all over again. So again, if you have 10 molds like this and you need to make 1,000 castings, it's much more convenient to having to recreate just the rubber part, not the entire mold. So that's one added benefit that larger productions will enjoy with this type of mold. And you guys can see that I also laid out some of these molds in front of me here, so you guys can see what type of castings can come out of these types of mold. Now, certain products that you may be working with require a specific type of rubber. For instance, we have a product called Crystal Clear, and if you take a look at the technical bulletin on the product, you'll see a section that recommends a mold rubber. And in that section, it calls for a specific rubber that you may need to use on a project. Now, that would be another reason why you want to make a cavity pour mold, just because you cannot pour the Crystal Clear into a product like Rebound 25, which is a brush-on mold product. And it would make not sense to make a block mold because it will eat up a lot of material. So a cavity pour mold would be beneficial. So now, as always, you want to keep in mind the post-finishing efforts that you're going to have on the casting that's coming out of that mold. A cavity pour mold will minimize any kind of post-finishing efforts, just because the way the mold is made and put back together in the production is going to minimize any kind of seam lines that you're going to have to clean up, just because of the construction of the mold. And you'll see some of that as I show you the models that I have prepared for you guys. Now, again, if you guys have questions, please let us know. We'll try to address those as they come in. Now, analyzing a model that you're going to be working with. Today, I'm going to be working, just to show you guys the statue here. And when I decided to make this mold, I already started thinking about the difficult areas on this project. So there we have openings between the arms, as well as an opening between the legs. So those are going to be difficult areas. And then I started looking around and figure out how to separate the mold once it actually is made. So you want to analyze your model before you actually start making the mold, because it's going to solve a lot of questions ahead of time before you actually get to the mold making part of the process. Now, not every model is great for cavity pour molds. If there's a lot of undercuts, or if the model is large, then a cavity pour mold may not make sense. A brush-on mold type would be a very good application for large molds. If it becomes too large, then the weight of the material will be limiting to you as a user of that mold, and also at that point it starts to eat up more and more material. So you have to make that choice when creating the mold. What's the best type of mold? Size and undercuts does matter, and you definitely want to make that decision before making the mold itself and determining the mold design. So the mold design itself, again, you want to think ahead. It will save you time, money, and work. A brush-on versus a cavity versus a block mold will make some determination about the process and the project itself that will, again, save you time, money, and work down the line. Now, the question about a cavity pours like this, where you create the outer shell first, is, do I need to vent the mold? And here you can see on this example, when I made this Buddha statue here, the pour spout of the silicone, where the silicone poured into the mold, and then you can see these two little antennas here on the side. Those were the air vents as we pour material into the pour spout and the mold itself starts to fill up. Those air vents allow air to move out of the mold and fill the mold completely. So it will help us to move the air out of the mold as the material is rising and prevent any kind of air bubbles that can trap on the surface or inside the mold in general. So air vents, while not 100% necessary, they will always come down to the size of the pour spout that you're putting into the mold. If the pour spout is not large enough and you just can't get enough material inside that cavity, then air vents like these will be absolutely necessary. So again, the mold design, you want to think ahead. Do I need a larger cavity for the pour spout? Or is the material viscous enough so it can flow directly in there without dragging on the support shell and the model and clogging up that pour spout? So a lot of thought has to go into the design, the material ahead of time.
Hey Milo, what's that silicone there? I think that might be like an EcoFlex or something like that.
So the mold here that I have in front of me, the Buddha mold, this is actually Dragon Skin 10NV. It's a very stretchable mold, and the reason why I decided to use this material is because of its viscosity. It flows very easy. You don't have to vacuum degas it. Because of the low viscosity, air bubbles just rise naturally to the top, and of course because of its stretchiness. And I knew I wanted to create these castings without a seam line on the side here. So I chose a material that I can easily make a glove mold out of. So I would consider this a glove mold slash matrix mold. And the support shell is made out of the Plasti Paste 2. And we'll touch up on that as well, on the different materials that you can use for this application, and materials that have been used in the past as well. Now, we kind of started touching up on the material flow, and it's really important to understand that you are making a pour-on mold. That means a very thick materials, silicones that are high in viscosity, will have a much tougher time to try to get into that cavity and not trap any air bubbles, or even just because of the thickness of the material, the viscosity, having a tough time squeezing into a small cavity opening. That is a very important part of this kind of technique. So the materials that you choose for your mold are very important, and you should understand them. Again, in the links below, there's going to be some information on our products, where you can also find charts off material so you have a clear look over as far as what the viscosity is, what the mix ratios are. It's a really helpful tool to help you decide which product will be good for your project. Now, overall, this type of mold design will always be more economic over a box mold just because of the amount of material that it's going to eat up. Now, if you guys have any questions about these molds here, please feel free to ask. I will gladly talk about it. These are all cavity pour molds that are either made here or outside, and we chose them because of their mold design. Now, as far as these molds, they are all made out of different materials, and since we are on material choices, let's talk about support shell material and why you would choose one product over another. So here I have a mold of a bear skull. This is made using freeform air. Outside shell is made using freeform air, while the inner silicone mold is Dragon Skin 10. So I wanted a soft silicone inside and a nice lightweight support shell that I can easily rotocast materials into. Easy to tell here that this is a cavity pour. Here's the pour spout for the silicone for the first half. And I'm going to be honest with you, this is quite small. I had a tough time pouring even very liquid silicone in it. So always learning from your mistakes. Larger pour spout would have been better. Here you can see the separation line of them too, and the silicone itself. You can see the separation line there where I'm pulling. So this is a two-part cavity pour. It's not one part that was cut open. It was two separate parts silicone cavity pour. And this is the casting that comes out of that mold. So freeform air support shell was used for this. Now, another option that you have for the support shell would be Plasti Paste. This is Plasti Paste 2 support shell. These are used for anything from small to large support shells. Nice and hard, easy to work with material. And it's something that's been used more and more over the past few decades. It's a more modern material, I would say, for support shell applications. More traditionally, at least when I learned mold making, we would use hydrocal, hydrostone, and plaster with burlap to make support shells. Now, while those support shells look something like this when they're finished, this is actually a newer product. This is a dual matrix neo type of support shell material. It is reinforced with burlap inside, but you can clearly see that this is a thinner application. This is about a little bit under ½ an inch on each side, but it's a very strong support shell. And I want to open this up and show you guys what this looks like inside. Well, we have our support shell that was, again, made first. We have some keys that are built in. And then if you look at the mold itself, it's very smooth. There's no keys on this mold that hold the mold in the support shell and help it register into the support shell. And the reason for that is that the rubber used here is quite stiff. This is a probably 40 to 50 durometer rubber. So it's very stiff and doesn't move very much, and that's why the person making the mold chose to make it nice and smooth on the outside and don't really need any keys to support it in the support shell. Now, this mold was made out of one part, and then it was sliced open on the sides to create a two-part mold. And you can see how jagged these cuts are, and because they're so jagged, they actually help register the rubber halves back together. So I just wanted to show you guys that. And the material that we're going to be using today is like this. It's a dual matrix neo. It's a polymer modified gypsum system. And it's very strong and can be used easily for the support shell as well as the casting itself. Now, one more option that I wanted to mention for support shells is epoxamite and glass fibers. Epoxamite is a laminating resin that is used with glass fibers to create very strong and lightweight support shells. So if you guys need that type of option, there's always different materials that you can choose based on your project needs. Now, the molding rubber that we're going to be using today, like I said, is MoldStar 30, which is a 30 durometer silicone. And the number one thing that I looked up when I chose the material was the viscosity of the silicone. It had to be low enough that material will flow. So anything about 15,000 CPS, which is how you measure viscosity in CPS, anything below 15,000 or around 15,000 will flow quite nicely and lends itself good for a cavity pour mold. Anything above that will have a very thick consistency and will not be ideal for that application, but even that can be changed by adding some silicone fluid, silicone thinner. So understanding the material is a really important part of the process. Now, in our silicone lineup, we have products like the MoldStar. We have Mold Max, which is a tin-based silicone that's often used for this type of application. We also have materials like Dragon Skin that you guys saw this mold made with. And those are all products that have lower viscosity and are readily available to be used for this type of application. So they will fit this application very well. Besides silicones, there's also urethane rubber that can be used for this. Urethane rubber like Vitaflex is great for concrete castings. PMC rubber, Rioflex are all low viscosity rubbers that can be used for a pour-on mold type of application, which that's what matrix molds ultimately are. Now, besides the material choices, we also have to understand the material handling and its importance. What do I mean by material handling? Be aware of manufacturer's instructions. Take a look at the technical bulletin of the material that you're working with if you haven't worked with it before. Is it called for premixing of the product? Then make sure that you do that. Premix the individual components before combining them will give you a much better product at the end, because you're going to incorporate all the product that's in those buckets, even if it has settled out. You mix it back in and then make your molds with that product. Double mixing of your material is also really important. After mixing the components in a clean container, you will transfer them into a secondary mixing container and mix them one more time. Now, everything that was at the bottom of your mixing container ends up at the top, and you actually can sometimes see that there's a difference in color if the material is colored. And you can tell that it's not mixed properly or 100%. So that's really important to get a good consistency of the material. Give the material a chance to fully set up and give you all the benefits of that product. And again, going back to the viscosity, importance of understanding how fluid the material is for this application. Does the material have a gradual cure or snap cure? Is also part of the equation, especially when you're making a support shell and you need to move quickly to build up all the layers. Then adding accelerators and understanding how they work for the Duo Matrix Neo is really important. So technical bulletin has a lot of information that you guys should be familiar with. Now, one thing that always comes up for me as I do support for these types of questions, a lot of time customers will have certain materials and want to know if they can use them for a particular application. At the end of the day, you can use it, but you have to understand your limitations. If you're using a super soft silicone and you're making a large mold, then that silicone needs to be reinforced and somehow held in the mold, and that's where you're going to make keys in your buildup, so that rubber that's now soft and pliable can find a key in the support shell and firmly be held in there so it won't distort. You can make a support shell out of concrete if you want to, but at the end of the day, it's going to be heavy and might not work well for the application that you have. So now that we covered some of the basics about cavity pour molds, again, I want to invite you guys to ask any questions that you have on the process, on the models that you see here. I want to show you one more model before I start cleaning off the desk here. And that's this little mold right here. I'll pull this up front. So we have a little figurine here, and the mold maker also decided to make a block mold, or in this case cavity pour block mold, and here's the mold itself that you see. So he cut it open, not all the way, just enough to extract the figurine. But I just wanted to show you guys that that's option 2. When you're under a lot of time crunch and you can pull off a cavity pour mold with a box mold, then that may be a viable option. And just so you understand and see how this is actually done, here I have the figurine. The artist, the mold maker, created a box, a mold box. Now this is out of wood. He could have also made this out of other product, but again, most economic, fast to put together, and then he basically put the mold box over the figurine. Now, it's important to make sure that this doesn't just float around, that you line it up so there is about the same amount of material all around the model. And your model doesn't actually touch one of the sides, because then you're going to have a mold that has a leak and is not going to be successful. So there you have another type of cavity pour mold that's actually a cross between a box and a cavity pour. So again, I'm going to just slowly move all this that we have lined up here away and make some space for our presentation. Again, if you guys have questions, please feel free to ask them. We'll try to answer them as we go along. Now, I already mentioned that we will be using the same model that we had used for our brush-on mold that we did on our last presentation. And again, just to mention it, the reason why I wanted to do that is to show you guys that there is other methods to do the same mold. It doesn't always have to be a brush-on mold. It doesn't have to be a pour-on mold. It can be other types of molds. You have to understand what's most economic, what's the easiest, and what you're familiar with. So here's the model that we're going to be working with. We already kind of went over the model itself. We identified difficult areas about the model itself. There's a couple of areas that may trap air bubbles, so I want to be aware of those as well. But the next step that you want to think about when you do have your model is how, all the things that you need to do to prep the model for the molding process. Now, in this case, the model is made out of urethane plastic. It's hard. I don't need to worry about damaging any of the surface on this model. So I can just start by applying a cover over it, a protection layer, and then building up the clay over it. If you do have a model that's made out of clay, you want to put a soft padding over it and then wrap it softly and easily around before starting the application of the clay. Now again, if you have a model that's soft and delicate, then you already determining in the back of your mind somewhere that the clay you're going to be using on here should be really soft clay. And in that case, I would opt for the wet clay or water-based clay. That's very soft, inexpensive, and pretty readily available. But again, that should be going on in the back of your mind as you're prepping and preparing your model. Now, this model here is adhered to the working surface using hot melt glue, and then using the same oil-based clay that we're going to be using. This is Sculptex. Let me show you guys what that looks like. Sculptex oil-based clay. This is soft version of it. So it's very pliable, it's easy to manipulate and work with. This is my go-to clay that I would use in any kind of molding buildup that I have to do, where for sculpting purposes, I will opt for the hard version of the same product. So a little bit of the clay is put around the base on the bottom, so that if there's a gap on the bottom of your sculpture, that gets closed up, so that when we make a mold, there is no material that's going to seep underneath the model. You can also secure the model onto your working surface by putting a screw underneath through the board into the model itself. That's a technique that we readily use in the foundry that I worked at, and basically secures the model from ever falling off of your working surface. Once you've been around mold making and casting long enough, you also have the privilege of seeing when things go wrong and bad and the molds fail. So in order for this to stay solidly on the working surface, you may want to put a screw through the bottom into the model itself. Again, something that you want to keep in mind as you're working with the model. Now, the next step for our model would be to wrap it with a protective layer. We're going to be applying the Sculptex oil-based clay over the model, which I have already laid out some sheets. I'll show you guys that as well. But like I said, we need a barrier layer over the model. And a lot of times, plastic wrap, saran wrap, a plastic bag can be put over it. The old sculptors used to wrap blankets and rags around their models. I'm going to be using some aluminum foil. Just going to get some of that ready. And the reason why I like to use aluminum foil, again, my model is rigid. I don't have to worry about damaging the model. But the aluminum foil wraps easily around the model, holds the shape very well. And again, I don't have to worry about damaging that model. Now, the arms here and the open spaces, I'm not going to poke through it. I'm just going to squeeze it so it's nice and flat. And then proceed to do the same thing down on the lower half. Again, there's different ways to do these things. Mold making is very versatile. There's many techniques for a lot of the same applications that different sculptors, different artists will use in different ways. So just because I'm using aluminum foil here doesn't mean necessarily that you have to use aluminum foil on your project. It's just what works for me here. Just a little bit more here. And then we can start building up the clay around the model. Now, remember, the clay that we're applying right now is going to become the actual rubber mold. So, there's a couple things to think about when you're applying the clay here. I'm going to start at the bottom and I'm going to build my way up. But before you even start building up the clay, the first thing you want to determine and think about is the thickness of the clay that you're using. So how thick the clay is here that you're applying is going to become the thickness of the rubber mold that you have. So the thickness here is going to become the thickness of the rubber mold you can see here over my shoulder. So you can see how around the head the blue silicone goes. That's the thickness that I'm controlling here now. So when you lay out the clay like this, you want to determine how thick the silicone is going to be. And for a mold like this, I'm personally going anywhere from 1/2 inch to 3/4 of an inch. I don't really want to go thinner than that. But that's kind of a standard rule for my molds that I make like this, about 1/2 inch thickness that you're going to apply. So these sheets can be rolled out into larger sheets. You can just put it into a roller and flatten them out, or you can do it by hand, by scraping, putting a bunch of softened material onto a board and scraping it flat until you reach a certain thickness. You can heat this material up to soften it up a little bit to make it more pliable, but you should not try to melt it. It's not meltable. So we're going to start with building off the base, and we're going to have a flange around the bottom of the mold here, and that's how wide this strip here is going to be. That's why I'm making this strip this wide. So this is my outer edge of the silicone mold, and then I'm simply going to start building this up all the way around. And this doesn't have to be perfect at this time. You're basically applying some material over the entire surface just to get a base.
Hello.
Yes.
Do you have any recommendations for the flange width, or is it just as much as you need to get a key in there to help it lock into the shell?
Right, so the question is about the width of this flange around the bottom. Is there a recommendation? Do we just need enough to put keys in there? And the answer to that is yes. You need to put some keys around the flange here. And just like you would put keys in a brush-on mold around the flange, we're doing the same thing. So that's why we're building this edge up. If you think about your brush-on molds that you made before, if you haven't made them, check them out on our YouTube channel. We made plenty of brush-on molds. There's always a flange around the bottom of your mold. It helps you with the process when pouring into that mold so the material doesn't spill all over your support shell. It keeps it kind of contained and allows the material and the mold to work good together. So we're going to just go ahead and speed through this and build up a flange around the bottom. And this is what I like about rolling out the material beforehand. You can then easily slice it and merge it back together, smooth out the surface. And then once you start getting to the edges where it actually goes over the model, what you want to do is you want to overlap. So you see how there's clay here but not here. So you want to overlap that same thickness of clay that you're building at the bottom. Again, that would be the thickness there in the mold. So you can draw that into the clay, and you see how I'm lining that up? That guarantees me that I have a good thickness in that area of the mold. And then I'm slowly going to shape that, push it down onto the model, and start building that up from the bottom, from the ground up. You can take larger sheets and then start wrapping the model with that clay. Now, again, you can be using different clays for these applications. Back in the day when the old masters used to do this, they used wet clay, water clay. Nowadays, a lot of people switched over and use oil-based clays. They're also recyclable. You can reuse them, reusable. And we're going to continue building up over the entire model. When you have gaps like that, I'm going to fill them and still maintain the same thickness, same shape of the area throughout. And then basically continue wrapping the model until we have a equal thickness buildup on the entire original. And you can see here why it's important to cover that. So again, because I'm using a hard plastic model, I don't need to worry that much about the surface finish, surface texture. I can just press into it. And then the area for the in between the legs, we're gonna press down to kind of shape to the body so that we don't have a flat, thick, flat area, but rather pressed in to conform to the contours of the body. Let's see.
In this case, Milo, you still have to be careful that you don't develop undercuts in this clay, because you are going to be making a mold that's going to have to register in a support shell.
Right.
Right?
So Jason mentioned the possibility of actually making undercuts while you're building the clay up, and that is absolutely correct. You can't just start building shapes that are overhanging. That's where you're going to get air bubbles trapped. If you have sticking out parts like that stick out, that's where it's going to be air bubble trapment when you go pour into the mold. So the shape itself has to be very slick, so to say, and can't have many areas where the air is going to trap. However, there is a little solution that you can do for that, to remedy that, and that is actually to cut air vents in the support shell. Before you pour the silicone, you're going to put a couple of air vents into the support shell so that those areas where you do have a difficult time with material going in or potentially trapping air, you can remedy it somewhat by having what they would call bleeder holes, or there's other terminology for them, but again, we'll show you that part a little bit further down in the process. And one thing I like to do is make sure to have nice clean edges on your buildup. The cleaner your edges are, the cleaner the mold is, and the easier it's going to fit back together. And when it fits better together into the support shell, that's in turn going to produce much cleaner castings out of that mold. So you can continue now building up the clay until you have the entire model covered. Now, once you have the entire model covered, you're going to turn and you're going to focus on a couple of things. You're going to focus on creating keys, as well as creating a pour spout for the material, how the material is going to get inside the cavity. So when I say material, what I mean is the silicone that the mold is going to be made out of. I'm just going to finish quickly around the head area here, because that's where we're going to be putting the pour spout for the silicone to get inside that mold. I'm just going to quickly go around the face area, turn this to you guys so you can see it. And again, because we laid out the clay in a very specific thickness, that's the way that we're controlling the thickness of the silicone eventually, what the silicone thickness is going to be in that specific area.
One thing I didn't want to mention that's interesting is when you talk about that flange, fitting into the support shell, the other thing is it's squared off on those edges, and that adds strength to the rubber as well around that flange. If it was feathered out, it would be a point where it could tear. Exactly.
Right, so what Jason is talking about, the flange here, you can see that the clay thickness here is same throughout everywhere. So by having the clay thickness here being the same as here, here, and the rest of the mold, it adds, not rigidity, but it adds strength to that lip. So when you do make a mold, that lip here is going to be much stronger just because it has that thickness in the rubber. Usually when you make brush-on molds, the lip here will be something like that. It'll be very thin where it comes down to a point. But when making a clay up like this, we can control that edge much better and create a stronger, thicker edge that, again, is going to withstand much more when you tug and pull on the material. Very good point there. Some of the aspects of mold making will then become more of a second nature to you as a mold maker, and they will just make sense in your head, and you will not even think about them. So, very good point there. Let's fill that as well. I don't hear any questions coming from you guys. That means that you guys are all experts on this technique, and I should not even be doing this. Again, feel free to voice any questions that you have on this technique, on the materials we're going to be using, or anything else that you want to understand about mold making and casting. And
someone actually did make an interesting point. He said that, you know, sometimes he'll make some keys that have a bit of undercut to them to help them lock into a support shell. Something you can only do with obviously a rubber mold. You know, do you think that's beneficial versus having just a squared off key?
So the question is it beneficial to have keys that interlock the mold, basically? Is that, I'm understanding that right? You have to be careful to understand how the keys do work. Sometimes the keys will lock the mold, and it will be actually more difficult to remove the mold. If you have opposing keys and opposing sides, and you try to tug on them, they actually create a mechanical lock and becomes very difficult. Don't get me wrong, those keys, those types of keys are actually very useful in certain applications. When I do large brush-on molds that span over a large area, I will often use mechanically locking keys that hold the mold inside the support shell and actually help suspend the silicone. So it's very good to understand what the keys do, what the function they have on a specific buildup, on a specific mold that you're doing. Not all keys are equal. Not all keys are meant for the same purpose. So understanding how they work and what they do in your mold is really important. And I personally would do larger applications of larger sheets of clay, but this is a somewhat difficult piece, so I'm using smaller bits. Now, once you have applied the clay itself, I think this is good for us here. We're going to focus on that pour spout that we're going to create. Again, this is a pour spout where the silicone is going to flow inside our support shell. Once again, we're thinking about the viscosity of the material that we're using. So if you remember the bear skull mold, that pour spout for the first half was tiny, and it made it extremely difficult to pour the silicone. So for something like this here, we're going to make a larger pour spout, and that's because we have to get a lot of material inside that mold.
Just to clarify, because some people came into the process kind of at this step, the model will stay on the board. The next step after we put all the clay on will be making a shell. After the shell is cured, the shell is removed, then the clay is removed, then the shell is reassembled around the model, and there's a gap between the model and the shell where the clay used to be. I know. And then the silicone is poured into that gap.
Sorry, you lost me like halfway through. I don't understand what's going on. No, I'm just kidding. No, Jason is actually absolutely correct. The process of making a cavity pour mold is just what the name says. You're creating a cavity that you have to pour the material into. And to create that cavity, you have to make this type of buildup first. You have to make the support shell, remove everything, put it back together, and then pour the silicone into. It sounds like a bit of a back and forth procedure, and that's exactly what it is, but it's a proven technique, a proven method of making molds that we know works, and it's still used by many mold makers. So it goes to say, if it's not broke, then why change it? Why fix it? So it is a valid method, and like we mentioned, some of the benefits and reasons why you would do a method like this keep this type of mold making alive, because it's still used by mold makers, by artists, by casters. So we have made a pour spout up to, at the top here. And one thing you guys are going to notice, it's not round, it's actually a rectangle that sits on top of the head. And you can see the edge here. Turn that a little bit. So that's where we're going to be pouring the material, the silicone, into. Now I'm going to attach on the side here. If you remember, this is going to be our cut side. This is where we're going to cut the mold open. And in order to cut the mold open, we want to have extra thickness on the silicone rubber there. When we cut into the mold, you want to have extra thickness of material so that mold finds a nice seat back together between the two halves. And you're going to actually cut it with a mold knife, to create a seam line, a channel that locks the two halves together. So this addition here serves two purposes. It's going to be a key that holds the two halves of our support shell nicely together. It's nice and clean. The support shell can find a nice fit on the clean lines. And it's going to serve as the cut line, seam line for the actual silicone mold. So we're going to press that on there and then smooth it out a little bit. And basically, the way that I do these type of buildups is I would build up the entire length off the separation line. And you can see that that separation line is not going to be always straight. It has a curve here. That's fine. You just want to make sure that the two halves of the support shell are going to come apart. So curves like this are necessary because the model is not just straight. So we're going to build that up. A little bit more at the bottom. Now keep in mind that I'm cruising at a pretty good speed here. I usually would take a little bit more time and make this a little nicer, a little cleaner. And once I apply the material, the clay, for that separation line, then I usually come back with a sort of a sculpting tool. Now this here is my little sculpting tool that I made out of a spoon. I'll flatten and cut the spoon, really easy to make these type of tools. And then I'm going to basically clean that edge off the clay that we built up. Start at the top here, work our way down. And then you come back and clean that edge just a little bit more. And that's how you create nice clean edges for your support shell. And I'm going to just quickly go down the entire length here Again, you first slice it, cut it, and then you come back with a softer edge and clean that up. Again, there's a couple spots here that we haven't finished all the way. Now, that is our separation for the cut that we're going to be making into the mold itself. A couple other things that we mentioned we're going to be adding here is keys along the bottom flange of the mold. And for that application, we kind of do the same thing. We use our little bit of clay, and we're going to cut this into strips. Now, these strips don't have to be as wide as the strip that we put on the side of the mold. These can be actually quite a bit thinner. So let's see, can you guys see this? Yeah, you can see that. See how the difference between this one and this one here? This one's much wider because we're actually going to cut into it. These type are going to go along the bottom. And basically that's a key that's going to lock the flange of the mold itself into the support shell. So once I put that down, I go back over with the finger, press it down firmly, smooth it out a little bit. And then just like I did on that separation line, I come back with the sculpting tool, cut the edge, create a nice seam on the edge. Do the inside as well. And the one other thing I wanted to mention about the size of this key, it doesn't have to be that large, the thickness of this here. It shouldn't be much thicker than the buildup that you did down below. If you go too thick, then you're just creating a deep crevice that material can get basically clogged in or tough to put that key back into. So they shouldn't be too big, too large. You can always, if you find that you apply too much material, you can come back and thin it out by scraping our entire thickness off of it. Remember, everything you make right now out of clay is going to become the actual silicone in the mold itself. Just going to close that hole because it did bother me a little bit just to see it. So that's the basic buildup. Now, when looking at matrix molds, you're also going to see, if you remember the Buddha mold that I showed you in the beginning, they will have sometimes strips going across the buildup. So you would see something like a line going down or going across this way. And those basically are also keys, just like down along the flange. Those are keys that help keep the rubber inside that support shell. Now, what the clay buildup should look like when you're finished with the clay, I'm just going to move this model out of the way and show you the next step. Put this right here. And here we have the clay up, what it should look like once you basically build up all the clay. And actually you can see here, I already started putting in some aluminum shims. We'll talk about those in a second, but I want to turn it this way. So you guys can see we have a strip key here going across. We have one up top here that goes across and goes up the middle of the mold. We have a key that we build up along the flange here. The lines themselves are nice and cleaned up. Everything is smooth. We have the pour spout up top here. If we can get a top shot, you guys can see. So this is my pour spout. It's nice and square. It's a large opening. That's how big the opening is going to be. And I'm confident I can get enough material fast enough in there to fill the mold. The other thing you can notice here is that this pour spout directly leads into the separation channel here. So as we're pouring the material in, those separation, the channels, the keys on the edges here, are also going to help us to guide and push material into the mold. So here on this shot, you can again see the flange that went around, and then also some of the keys that are part of the entire buildup. So this is basically what your clay up should look like. You can still see the figure underneath. It's a very soft version of it. We put about 1/2 inch of clay over the entire model, plus the thickness of the separation and key lines. Now, we're ready to prepare this for the support shell itself. So we're going to start making the support shell. And as you can see, I already started laying out a separation line for the support shell. We're going to split this mold in two. That's how it's going to come apart. And those separation lines that we're going to cut, that's where I started already putting in these aluminum shims. Now, there's different ways to go about separation lines like this for a support shell. You can always use wet clay, water clay to put over this. The nice part about that is because it's water-based, it will not really contaminate your oil-based clay. You'll be easy to remove and clean it off from that. Another way is what you see here with the aluminum shims. And I've also seen and heard of many people using things like playing cards or business cards, and they stick them into the material and use that as a separation device. Now, I can simply go ahead and press these shims into the clay. And before I go any further, let me just mention something real quick for you guys that never use these kinds of things. These are aluminum shims. This is flashing that you can buy at the hardware store. It comes in a strip, a long strip in a roll. And I basically cut these up into strips that I can use then for this application. They come in different thicknesses. The thinner they are, the more flexible they are. The thicker they are, the stiffer they're going to be. And the first piece you saw me put in here actually has a key built into it. These are keys that are made for the support shell. So the support shell itself has something to find and register into. And the way that the keys are made with these shims, I'm going to show you that really quick. If we can do an overhead shot. I have my aluminum shim here that I already pre-cut. And I'm going to simply fold it over half onto itself. Give it a squeeze here, not all the way. You don't want to break it. And then once you have that, it's kind of a V shape. Let me show you. That's a V shape. Oh, it's hard. There we go. Watch that, it kind of disappears when you hold it at the right angle. Cool. So then what you want to do is you hold your fingers at the depth of how far you want the key to be, and you fold the wings back out. And that's your basic V-shaped key. And based on the size of the model that you're working on and with, the mold that you're creating, these can be very different in size. Also, some people make different shapes, but very easy, inexpensive to make keys for your support shell. Now, when you're putting the keys into the buildup, the clay buildup, you always want to have them face the same way. So if the V shape is facing to the back of the sculpture towards me, then all the keys that we're putting into that should be facing the same way. And the reason for that is so we don't create areas where keys point one way and then we could actually create an interlocking mechanism between the two halves of the support shell. It doesn't happen all the time, but again, you want to prevent these things from happening so that you don't have to deal with these issues down the line in your mold making process. Now I'm going to go back into the clay with more aluminum shims that I'm simply going to press into the clay. And I'm going to build this up all the way. You can see I already did the other half. The other side is done. Now, like I said, the really nice thing about these shims is that you can actually somewhat bend them and twist them to create more of a custom shape that you need for your application. And then, of course, you can easily cut them to the size that you need them to be in. Now, the clay itself usually holds these in place quite nicely, but if you have to, you can come back and put some tape around the edges here if you need these to stick better together or more closely together. And like I said, the really nice thing about these types of shims is that they're reusable. You can always use them on your next project once you're done. And as a matter of fact, I have an entire box off these that I can scavenge out of for the different projects that I might be working on. There it is. Now, one thing that I like to do is go around and trim these edges. If there's any corners that are sticking out, I just kind of go around and snip them away so that we have a nice and clean edge all the way around the model. So when you go and apply your support shell and you're applying your material, you can run your tool across the edge to control the thickness of that edge much better than if you have places where it just keeps snagging on. So now that we build up the aluminum shims, we're ready for the application, well, sort of ready for the application of the support shell material, which again will be Duo Matrix Neo. But before we go that far, we're going to use some sonite wax to apply to the aluminum shims, as well as the clay and the working surface. Sonite wax is a recommended release agent for Duo Matrix Neo product and works well on multiple different surfaces. So we're going to apply it to the shim, to the working surface, and then to the clay as well. Now, technically speaking, you don't have to apply it to the clay. The clay has natural release properties, so it will peel off, no problem, but you will have a much tougher time because of the adhesion properties between the two products. You're going to have to scrape the clay out of the support shell, which we will be showing you as well what that looks like. So, just going to go around this really quick because I will be mixing up some Neo, and I'm going to show you how I go about applying this onto the support shell. Again, you guys, if you have any questions, please feel free to ask, voice yourself, so that we can answer them as they come in.
Somebody just mentioned he did have questions, and then you explain it as we go along, so it takes care of it.
I try to cover everything about this process. As you can see, I can't work with my left hand very well. So let's switch that up. I try to explain everything about the process that we're doing that's important, that you should understand, and encourage, of course, people to ask questions. I always think it's funny when people say, oh, I have a silly question about this or that. There's no such thing as silly question. You're asking because you don't understand, you don't know, and we're here to help you make that decision, make that call. All right, now that we apply the sonite wax, we can let that dry. And in the meantime, I'm actually going to go get a drink because all this talking makes me thirsty. We're going to focus on mixing up a batch of the Dual Matrix Neo. This is a polymer modified gypsum system. And I'm going to show you how to add some additives to the Neo to further manipulate the product so it can better work for your application. So, now, the Dual Matrix Neo is a 2-to-1 mix ratio by volume or by weight. And if you guys notice, I've already dispensed the part A, but did not dispense the part B. If anybody wants to take a guess why that is, you can go ahead. I'd love to hear from you guys. And as always, you want to follow the instructions off the manufacturer. So if it says shake the material, make sure to do so.
So before we go further, somebody did have a question just now about the key on your flange, how it's squared off, right? Isn't that going to be a spot where it's going to trap air when you pour the rubber into that?
So the question is about the key that we made on the flange at the bottom. The key itself is a raised surface, so it goes straight up. And the question is, when we pour the silicone into the mold and the silicone makes it down in here, won't this key here trap air and just not going to cast? There's just going to be an air void in our support shell. And here I just want to show you guys so you understand what that question really means. So here's our support shell, and as we pour material into the shell, there's these key areas that we have, right? There's one across, and then if you look down at below, no, I gave it away, sorry. So here's the key down at the bottom, the square one, and you can see there's little air holes, vents, in that channel. So those vents there in that channel will allow the air to move out of the cavity as we're pouring the silicone in, making sure that that gets filled solidly with rubber. A very good question there, you're going to see me actually drill some holes into one of these support shells before we pour the silicone. So you'll get to actually see what that question details. Now, any answers on the reason for not dispensing the part B? Yeah, in the back there, yep. Something about air sensitivity. Oh yeah, so the reason why we didn't dispense the product is the Dual Matrix Neo Part B, if you just dispense it and leave it at room pressure, room moisture, room temperature, it will actually start to build up a skin over the top, just like milk kind of would. And basically the top layer will start to solidify. So I always wait to dispense the sensitive material till the last second. So again, this is a 2-to-1 mix ratio product. We have 2 parts of the part A, 1 part of the part B, and I'm going to be mixing this with a paddle mixer. This is what that looks like. Now this has been used already heavily by me, but it's something that we would recommend using when mixing the Dual Matrix Neo. So you can see those paddles in there, like a little propeller. And we're going to be using a mechanical mixer, so this is a variable speed drill with the paddle mixer. And since we had a huge explosion with the Dual Matrix Neo on my last presentation, we're going to be opting out to use larger containers so we don't have that issue happen again. If you guys want to see that, make sure to check out our other live presentations we did. That was quite interesting. So we're going to go ahead and dispense the liquid component into a clean mixing container. Again, scrape your containers because there's a lot of material left in there. And then we're going to sift the dry powder into the liquid as we mix it. You want to tilt the container when you're mixing the product like this so that you actually submerge the entire paddle mixer in the product. So I'm just going to mix this for another 30 seconds. So the material should have a nice creamy consistency when it's mixed. It's quite liquid. You can still pour it very easily. For the paddle mixer, I always have a water bucket near my workstation when working with this product. So I just like to quickly clean this off by running it into water. It helps with buildup of material on your paddle mixer. Now, because this product is very liquid, it's not going to keep a vertical surface very well. So there's actually a product that you can use to thicken the material. This is a matrix thickener that we're going to be adding. And because I like to work a little bit faster than what the product has for work time, we're also going to be using an accelerator. The accelerator is a powder that you should mix into water for actual mixing with the Dual Matrix Neo. The instructions for that are, of course, with the material itself in the technical bulletin on the Dual Matrix Neo, as well as the accelerator powder. Now, because I'm adding additives to the material and I want to control the work time and, in this case, the thickness of the material, I want to be using an accurate gram scale so that I know exactly what to expect from the material. Now, again, information on the additives is on the website, on the technical bulletin, so you should check that out so you understand what you're working with. Now, I'm weighing these out based on the amount of material that I mixed up. So what you want to do is you want to zero out the mixing container. We're going to remove that. Now put the material on there. Once you understand how much product you have, you can zero that out too. And then you can focus on how much product as far as the accelerator you're adding. Now when adding the accelerator, make sure that you're actually mixing the material. So here we go. We're going to do that right now. Okay. A little bit more. And again, we're going to mix that thoroughly for 30 seconds. Again, submerging that paddle mixer in the material completely. Hey, Jason, can you do me a favor? Can you grab me some chip brushes? Because you're never prepared as much as you need to be. And then once you add the accelerator, I can go ahead and add some of the thickener. Now again, the thickener is for vertical applications, makes the application on vertical surfaces much easier. Thank you, sir. All right, and we're gonna add the thickener as well. And again, this is added by weight. We zeroed out the scale. Now you're going to see an instant change in the consistency of the product. And if the material is just not thick enough, you can add a little bit more, but again, you want to keep within the limits of the technical bulletin recommendations. Just going to add a little bit more. Keep the eye on the scale. You can see that the material is much thicker now. You can see how thick that is on the mixing paddle, on the paddle mixer. I'll clean that off. Again, you want to clean the material off the mixer as soon as possible so that it doesn't have a chance to bond to the mixing paddle. Now we're ready to apply the material. So it'll be our first layer of the Duo Matrix Neo. And I like to dump out some material right at the base and then start spreading it around. And you want to go about 1/2 inch to 1 inch over the actual clay buildup that we did. So you want to have another flange off the support shell material. Then you can start working the product up the aluminum shims, including the keys, and then focus as well on any sharp corners, sharp edges that you may need to push the material into. So underneath here, and then along the entire perimeter, of course. And basically, you want to build up about 1/4 inch, I would say, maybe a little less than that, of thickness with a thickened layer before starting to apply any glass fibers into the buildup. Now, by adding the accelerator, we're allowed to work much faster as far as the entire mold buildup goes. So instead of having to wait for a long cure time, this allows us to move fairly fast and continue to build up the material without actually delaying in between the layers. So by the time I'm done applying this layer and have the chance to dispense the material, the previous layer will already have partially set up where we can apply more material to. Now, make my way around. And you can also start applying material up top.
You know, somebody brings up a good point. Why not use a resin like Smoothcast 300 for something like this? I mean, I can think of a couple reasons not to, but maybe you want to discuss the difference between that and something like Neo.
So the question is, why would you use the Duo Matrix Neo and not a resin like the Smoothcast 300 or Freeform Air or other products? And the straight answer to that is actually, there's a few answers. Cost is number one. So the cost between this material and the smooth cast is quite different. This is going to be a much cheaper alternative for this application. So that will be number one for me as a mold maker. What are some of the other reasons? Availability. What else? Weight. All kinds of different reasons, but number one for me would be really the cost of the material. Why go and buy a Mercedes if I can just drive a Yugo, you know? They both will get me from A to Z. It's just what you want to use, how much money you want to spend on a particular product, or in my case, on a car, would be the main factor driving these choices.
Personally, I'm not super fast at mold making. So if I can use a material like Neo that has like a 30-minute open time, I'm really happy with that. Along with, we've got options in the epoxy line that have a long open time. Freeform and things like that are really easy to use without additives right out of the box.
So Jason brought up the working time aspect of the material. And I do have to agree with that to a certain extent because I do like faster setting materials personally. I will always opt out for the faster setting materials. So if you want to see a support shell made with Smooth Cast 300, there's a video we did not too long ago on a glove mold on a hand where we did that technique because I needed a very fast setting material. Smooth Cast 300 was ideal for it, and that worked very well. Now, something that Jason brought up that I kind of remember now is the fact that there is a work time with the product. If you're working on a large mold and you cannot cover an area with the batch that you're mixing, that you mixed up, then for the next batch, you should keep that in mind. Minimize the amount of material that you're mixing. That's going to allow you to work more efficient, waste less material, and be more efficient at what you're doing. So yeah, work time is a good aspect of the material to keep in mind, and maybe a choice driver why you would go with one product over another. But at the end of the day, you are the one making that decision, and you have to make the decision as far as do you want to use one product or another, and what the benefit is to one over the other. So this is the first layer of the buildup. The second layer is going to have matrix chopped glass in it. This is matrix chopped glass. If you guys would like to see a support shell made with the matrix chopped glass, we actually did a support shell video using the Duo Matrix Neo that we posted not too long ago. So if you want to see a complete buildup with the use of the chopped glass, with the use of the accelerator and also the thickener to help the project, you can go check out that video. There's a link in the description below here. Now, I'm going to clean this up and move over and on to the next model. I'm going to put this right here so you guys can see it. Yeah, part of it. That's good. Now, once you're done with the first half of your support shell, this is what you should be looking at. We have the first half completely done. It's a bit rough around the edges. You can still kind of see and make out the model underneath: head, chest, one of the arms, shoulder here, and then the legs. Now, when you turn this around, this is what you're going to see. You're going to see the aluminum shims and the second half of the clay buildup. Now, I like to clean up some of these stragglers that stick out over the edge. I basically take a razor knife and then come back and just trim that a little bit back. Doesn't have to be all the way, it doesn't have to have a finish line, but you're going to trim that back a little bit just so you can have access to the shims. And then you're going to remove the shims. Just going to go around here. You can see the reason for cleaning that edge. It makes the shim removal much easier. Shims are out. They're going into my shim recycle box so I can reuse them tomorrow again. I know I have to make another matrix mold. Yay. Now, one thing that I want to draw your attention to is the fact that this lip now here that we removed the shims out of, it kind of has moved a little bit. If you can zoom in on that, I would like to show you guys exactly what, you see that gap there? Here we go. So that has shifted a little bit and created a space where now silicone and actually the Dual Matrix Neo for the second side will seep into. So you just want to be aware of these things. You can push it back a little bit with your fingers. And then if you want to really clean it up, you can come back with a sculpting tool of some sort and clean up that edge a little bit, making sure that there's no edge where the material can seep into. And you're going to do that all the way around on both sides of the support shell. Now the next step before applying a layer of Dual Matrix Neo to this side of the shell would be to actually put a seal and release on this edge here of the Dual Matrix Neo. And for that, again, we're going to be using the Sonite wax oil for the sealing and release application of the Neo. So again, we're going to put some release agent on the Neo directly here.
You did make an interesting point about cleaning up those edges. There's also these plaster rasps, these, I think they're called Surefine or something like that, where it's a rasp you can use to clean the edges of those as well.
Right. So comment came in about cleaning up the edges here, that you can actually use a rasp to clean them up. That's absolutely correct. That's the way that we used to do it back in the foundry, where I learned a lot of these techniques. Of course, the plaster being a softer product made the rasp a very easy tool to use. Now, the Dual Matrix Neo is actually quite a bit harder material, and you will discover that a rasp may not work as well as you think it might. I've tried it. What I end up using for the cleaning of the edges is actually either a palm sander with a rough 40-60 grit paper, or I actually like to hop out and use the 4.5-inch grinder. 4.5-inch grinder you hold in your hand and just chase the sides. Now, it is a dangerous tool. If you've never used it, you should definitely have somebody show you. It can easily harm you. So before using any kind of power tools that you're not familiar with, have somebody either show you or do it for you, again, because it is a safety issue or concern. So once you apply the Sonite wax to the edge of the Neo here, you can clean up any of the stragglers that we have of the dried Neo that fell off. You can blow that off using an air hose so they're not present, and then we can go ahead and repeat the same procedure and apply the material to the second side. But one key feature to this is to make sure that the support shell is going to line up with the model that's underneath there in this exact position. And One way to do that is to make more keys. So I'm going to use a larger size drill bit. And then around the perimeter here, we're going to put a couple of indents so that the support shell that we're creating, at least on the second half, will find those keys, those indents, and register into them and find its specific placing where it belongs so that it fits perfectly over the model that's secured underneath. So again, just a couple of small indents. We're not drilling holes. We're making small indentations. Excuse my... There we go. So we clean those up a little bit. And because it's exposed wood particle that is very porous, make sure that you put some sonite wax into them as well. That will seal that wood inside and prevent the dual matrix neo from adhering to that wood. So those keys, again, will help us align the support shell perfectly on the working surface so that it will fit perfectly around the model. All right, so let's just go ahead and mix up another small batch of the dual matrix neo and show you guys how that's applied to the other half, to the second side. Always make sure you wear gloves, protect yourself. And just like previously, I pre-dispensed the part A off the dual matrix neo, while the part B still needs to be dispensed. Got my thickener. A couple of holes here. All right. Got our paddle mixer ready. Now I can dispense the part B of the neo. And this is a 2-to-1 mix ratio that I'm using here by volume, so I can simply mark the cups for that purpose. Let's see. We're going to dispense our product into the mixing container. And then we're going to mix the liquid while we sift the dry component in. A little bit of water, wash off the mixing paddle. And for the second side here, I don't want to show you guys the addition of the accelerator because it doesn't matter really. I have plenty of time to work on this. We can just simply go ahead. Remember, zero out the scale. Okay. And then we can add the thickener. Again, the thickener I like to use on vertical surfaces because it helps with the material application. peel away, and again, just like I did previously, I'm going to dump out a little bit of material at the bottom here, and then start working it with a chip brush. Now, I won't be doing the entire buildup here off the support shell. I just want you guys to see how this is done. If you want to see the support shell being made completely, again, there's a Dual Matrix Neo video that we just released on making support shells with the Dual Matrix Neo. You can see I'm applying the material over the first half. And the one thing I wanted to mention here is that based on the size of the mold that you're creating, you can and should vary the thickness of the Neo. If you look at the technical bulletin, there is recommendations on the thickness that you should apply the material to. And keep in mind that if the mold is smaller than, half a foot, then you can vary that to be a little bit lighter, so the mold is lighter. And if the mold is bigger and you need more support, then you can make, of course, the Dual Matrix Neo a little bit thicker application so that you do achieve that 3/4 of an inch thickness. They'll give you plenty of support. Now, the other thing I wanted to bring up is the thickness of the support shell throughout. And what I mean by that is that when you build up the support shell, you're the one that has control over the thickness. You're the one applying the material. So you want to control the material so that the edge of your support shell here is the same thickness as it is somewhere in the center of the mold. So the edge here should be the same thickness as it is anywhere else in the support shell, so that the edge itself is just as strong as the rest of the support shell. And for this, I'm aiming for about 1/2 inch of thickness on each side of the support shell. Again, I'm basing that based on previous molds that I've made with this material, the mold needs, what I'm going to be doing with the mold, and the strength that it needs to survive the casting process multiple times. So the more you work with these materials, the better you will have an understanding and feel for them. Don't be afraid or scared if a mold fails. It has happened to me. It happens to most mold makers. Sooner or later, we make mistakes that end up costing us a mold or two. So again, this is just the basic application of the material. I'm not going to finish the entire support shell.
Before you move forward, quick question on the reinforcement. Obviously, you've used burlap for a plaster support shell. You wouldn't really use that with Neo, would you?
Would you use burlap as a support material with the Neo? The basic answer to that is you can. Am I going to use it? Most likely no. Why? It doesn't add that much strength. It's just burlap. It's fibers, cloth fibers basically. Whereby glass fibers, once they're impregnated and merged into a liquid product, become very stiff and very hard and add a lot to the stiffness and hardness. I personally wouldn't use the burlap with this material. Like I said, we used it on plenty of occasions on support shells with plaster, and it's a very basic material that I've learned support shell making with. I just feel like there's better product out there that will do much better for this type of application. That is not to say that you can't do it. It's just that my personal preference is no. However, going back to this mold here, if you take a closer look, this mold is actually made with burlap. There is a burlap texture in there. You see that right here? So there is burlap in here. So the mold maker here used burlap in his buildup. It comes down to your personal preference, what you already have used, what you know how to use. So that's kind of the answer to that. I personally like to use the glass fibers because I know they're very strong and readily available, and just add extra rigidity strength to my buildup. Now, the next step would be to remove the support shell from the clay buildup that we've done. Now, at this point, I've already finished the support shell. The edges, as you can see, have been cleaned up. The edges are nice and smooth. They're not sharp. There's no glass fiber sticking out. And that is done with a grinder. 4.5-inch grinder is what I like to use. Again, if you're not familiar with tools like that, you shouldn't be using them. You should ask somebody. You can use a palm sander with a rough sanding pad. It just may take a little longer for that. But you can see here, if we can zoom in one more time, please, on this edge. You can see that, you can kind of see where the separation line is in there. There's a little bit discoloration in the middle. And you can see that the two halves of the support shell are about equal thickness. Overall, it's about 1 inch thick. And the thickness of each individual part are more or less even. And that's kind of what you want to aim for when you're building up support shells. Same thing with the silicone mold underneath. That thickness of the rubber should be about the same. Now, we cleaned up the shell, clean up the edges. It's time to open up the shell and retrieve our clay out of there. So the way that I do this, I would start down at the bottom where I have a nice clean edge. Tap it a couple of times so you can see a crack of where that support shell separates. And then I slowly gonna make my way in that gap with a tool. And you can kind of hear the support shell cracking because it's opening up. Now, I'm not going to continue up the entire separation line with the metal tool, just because I don't want to be damaging the edge the entire way up. So I use these wooden sticks, tongue depressors, and I would slowly tap those in. And I don't mind if they break when they do break. I can remove this tool out. The wood is going to be much gentler on the materials than a metal tool would be. So I'm going to make my way around the perimeter here and slowly open that up. Pry that open a little bit.
Milo, some folks are talking about adding some pry points to the shell, using some clay wedges or something like that that you can remove afterwards. What do you think on that?
So the question is, or the comment is on pry points that you can build into the support shell that are clay that you can then scrape out, and that becomes a point where you can put extra stress, extra pressure onto the support shell. That is absolutely viable. I would definitely recommend doing those. It's just when you doing a mold like this, you're going to think of every technique every time, and then maybe next time you do a mold like this, then you will think of it because it will make your life easier and employ that technique. Now, one thing to keep in mind here that there's a lot of suction right now on this buildup. The material that we apply was liquid, and it was applied over a clay. That's also a tacky material, and that's going to have a lot of suction to it right now. So go slowly at this point. Don't be hitting on the mold with hard tools. You want to go as slow as possible, basically. And then we're going to make our way to the top. All right. And then we're going to slowly move over to the other side. Again, moving slow is the best prescription here because you don't want to be applying a lot of pressure onto something that's stuck together very much. This will be the hardest removal that you will have on a model like this. Keep in mind that the first time you remove a mold off of the original model, the support shell, that's the hardest it's going to be. Everything after that, it'll be easier and easier. Start again with the metal tool. No, that's breaking apart. All right. All right. All right, so I think we got a good break. Yep, so we can slowly now pry one off of the other. And for that, I like to bring out the big mixing stick here. And we're going to slowly pry this apart from each other. You can see how don't need that anymore. All right, I think we broke the main seal here. All right, so now we can pry that mold open. Ta-da! Oh, there it is. All that effort that we put in is now coming apart. The mold is opened up. We're just going to put this aside, and I'm going to take the model and move it aside, and we're not going to disturb the model as it is. We're just going to leave it on the working surface. Again, we're going to put this aside here so we can focus on our mold. So we have the aluminum foil here. We can peel that out easily. And now we can work on removing the clay. Now this will be probably the hardest part of the project, where you actually have to remove all the clay out of the support shell. You can throw this in the oven at low temperature to soften up the clay if you need to. And some mold maker and artists will swear that removing of the wet clay, water clay, is much easier than removing oil-based clay. and to a certain extent I can understand and agree with that. But again, if you soften up the clay by warming it up, the removal process is much easier. Now, once you remove most of the clay out of the support shell, you're going to come back to the shell with some isopropyl alcohol and a chip brush with hard bristles, so trimmed bristles, where you trim the bristles off. And we're going to use that then to scrape out and clean out the last residue of the oil-based clay out of that support shell. Just going to clean up my work area here a little bit. Pardon me. Now, what that support shell should look like over there. That support shell should look something like this when it's cleaned out. All the residue has been removed. We exposed our channels that are in the support shell. Here's the other half. And as you can see, it's been cleaned quite a bit. All the clay's been removed. One thing I like about the process of removing the oil-based clay, when you scrub the last residue off the oil-based clay with the isopropyl alcohol, well, that solution between them two helps to seal the surface of the Duo Matrix Neo. So this is quite nicely sealed now, and I don't have to worry about the silicone sticking to this half. But what we do have to worry about are those areas that are potentially going to trap air bubbles in them. As we mentioned earlier, the channel along the bottom here, the key channel, we already put a couple of holes in there. There's, you can see a hole there, you can see a hole here, and you want to make those now in the support shell where you can control where you're putting the holes into. You can also see that I put a couple of holes in here, and that's because this is a cross section that goes in, and I'm worried that air bubbles are going to catch along this top edge inside. So by putting a couple of holes there, it's allowing the air to escape out of the cavity that we created and out of the mold, so that we get a nice, good, solid rubber mold there. So the one other area that I'm worried about having trouble with is the crotch area of the model. There's a little bit of an undercut there, and I want to make sure that I know when the mold is filling up with silicone. I want to know when it reaches that area. So I'm going to put a hole somewhere right in there as a sign of how far the silicone has filled that cavity. I'm just going to quickly put a hole in there. Now, I don't really have to worry about these channels going up. This is sloped, so any air is going to trap in here is going to travel and up out of the mold, whereby the ones down below here won't. And again, this is just a hole for visual effect, so I can see when the silicone reaches this level of the mold, it's going to start to seep out of that hole. And then we know that the mold is filled up that way. But the reason, again, why I'm doing that particular one is a air vent for a difficult area. And when the silicone gets to that level, I'm going to stop pouring, and I'm going to tilt the mold a little bit back and forth to allow any air bubbles that are inside to dislodge and move up and out of our material. One other thing that you want to add to the bottom of your support shell are a couple of screw holes that we're adding to the bottom, because we will screw the model into the board itself. So just a couple of holes there. And the reason for that is that when you're pouring silicone into the cavity, that silicone has pressure and it's going to want to lift the support shell off the working surface. And when you add a couple of screws into that, that's going to prevent that from happening. Something that you should keep in mind as you're making the support shell, it's a really important aspect of it that could prove really important down the line when you're pouring the silicone. So again, this side, the back side, I'm going to put a couple more vent holes in areas predict the air is going to get trapped in. Oh, that wasn't secured. And again, in the bottom, in that channel, I'm going to put a couple of holes as well. So even if you discover that there is an area in your buildup that might prove difficult, that's a way to actually open that area up and allow silicone to fill completely. A couple more holes down at the bottom for a screw or two. And our support shell is pretty much ready to go. Just going to make sure that these two fit perfectly together. And there you have it. That fits good together. There's no large gaps. Looks good. So we're ready now to focus on the model itself and put this aside. Now, in this case, our model still has that aluminum foil on it. We can go ahead and remove that. And if you remember, on the last model, we put a couple of indents here at the bottom of the flange. And those now are going to be very crucial to align the support shell back around the model. Now we're going to need some hot melt glue and some Sculptex soft clay. I already rolled these out in little snakes, or a big snake in this case. We're going to use this as a preventative measure to stop any leaks. Show you guys how to do that. And we're going to set up our drill so we can put a couple of screws into the bottom of the support shell.
Milo.
Yes, sir.
The bottom of that that left arm. Did you need to? No, the other one. Do you need to put a? Actually, his right, my left. Do you need to put a vent or anything in there? I mean, the castings come out perfect. Do you have to kind of rotate it around in there? Okay.
So the question is, do we need to put an air vent here on the bottom of this arm? If we can zoom in this, please. I'm going to talk about that for a split second. So the bottom here, as you can see, you see how it's freestanding? There's nothing that connects this tip here to the leg. That's actually up here where it's connecting. So when you're casting this upside down, this is where potentially an air bubble will trap. Can you add an air vent here? Yeah, if I was adding an air vent here, it would directly connect to the leg somewhere, so down below. It's on the outside here, easy to clean up, so it wouldn't be that difficult to do so. Am I going to do that for this model? No, I'm not too worried about this. I know that in my casting process, that is going to be taken care of. When I cast this, I already determined that I'm going to cast it with the Dual Matrix Neo. Because it's a plaster-based, a gypsum-based product, it does best with surface finish when you do a slush casting first into it. And that eliminates pretty much any kind of issues I'm going to have with that area. Now, it's really nice that you brought that up, because when you go to then eventually cast into your mold, the first casting that comes out of that mold is not going to be 100%. And what do I mean by that? The first casting is always kind of a discovery casting. You figure out and find out where there's difficult areas in the mold. Are you using the correct technique for what you thought is going to be the best? And also, you're going to find out what kind of limitation your mold / casting is going to have, and the material that you're using. So at this point, I want to show you guys really quickly the first casting that I got out of that mold. If you notice, has no feet. So I discovered that the casting itself, the casting medium, is not strong enough to hold this small of a diameter and hold that sculpture up. So the feet themselves were too thin for the material. The solution for that, I had to insert rods into the cavity in the casting process. And I kind of already determined that along the way that will be happening, but I did want to show you that here. And why I brought this up, you see this air bubble here? Ta-da! That's exactly what Jason was just talking about. So you can see that there was an air bubble that trapped in there. Because this was my first casting, and I was just trying out the mold to understand how it works. I already knew I'm going to be rotocasting a layer in there, but I did want to show you that he's absolutely correct. That area could benefit from an air vent. I also understand and know that this is a thick casting material, so an air vent like that will most likely be clogged very easily, rendering it possibly useless. Either in the casting portion, you should be aware of the materials you're working with, the design of your mold, and how it's going to work in the casting process. A very good point that you brought up there. So, we have our model ready, the board is ready that we're going to be working on. We're ready to put the support shell around the model that we created. You're going to have a quick look over the model, make sure that everything is ready to go. The model didn't move. It's still in its original place. So we're pretty much ready to go. At this point, you could apply a layer of release agent on the model. Use release 200, since we're using silicone, would be applied over the model. It is not necessary. It will help with the demold, but I've already tested and proven this, that for my model application, I just don't need it. And I also don't want to be spraying the release agent without having an evacuation for it, so plenty of air movement. Now there is a little bit of dust here at the bottom of the board. You want to work that off. Make sure it doesn't get into your mold that you're making. And then we're going to take that support shell that we created, there it is, and put it around the model, or rather said, secure it around the model. So here's the back of the support shell, and again, we're going to find its resting place by the little key holes that we made into the working surface prior. So you can see those right there, and my support shell has the positive of those. So those are going to now find a home in there. You're gonna put it around the monitor. There it is. So it's secured into those, and the shell doesn't move. And you can see now the cavity that's forming around the model. You can clearly see, sorry, there we go, in between there, between the model and the support shell, the hollow space. Now, one thing I wanted to bring up before we close up the mold is this open area between the legs and between the arms. Please take a look at the brush-on application video that we did on this model on our live presentation. It deals with those open spaces, and it gives you alternatives of how to go about those spaces. So in our application, we're going to be cutting that open with a mold knife, a razor knife afterwards. But it's a very difficult area. When you have a stiff rubber, that becomes quite difficult to do. We did a lot of sweating trying to demold that original out of that mold. What you can do is create these shims out of laminated paper or plastic. This is laminated paper that we use in the shop. Nothing on the back, some print on the front. There's bubble sheets that I show in the last video. But what you can do is take this and then set it up in that cavity. Remove this for a second. So you would set up these cards that you pre-cut in the cavity, and while it doesn't touch all the way around the model here, it touches enough so you can lodge it into the space and it would stay there. What happens is you pour your silicone around it and it fills the area and keeps that card in place. So now when you demold the mold, all the space where you have the card is free and you can easily remove it. Only a couple of areas around the perimeter is where you're going to have to trim the mold open. So a very interesting technique for that area. I'm not going to be employing it on this, but I just wanted you guys to be aware of the possibilities, its existence, because it will make your life easier than having to cut that shape here in a difficult area. So let's get back to our support shell. Just a quick drink. Everything looks good, fits well. All right. So you can see now our pour spout here up top, how nice and wide and big that is. We'll be able to pour the silicone into that no problem. Now, the edges of our support shell, I'm actually going to use some hot melt glue to put that together. Now, this is two functions. It helps the two halves stay together firmly. It also will prevent any type of leaks that may develop around the perimeter of the support shell. Now, I'm doing the same thing down around the bottom. All right, I'm just going to hold on to that for a second while the hot melt glue cools down. And in the meantime, I'm going to position and place the screws into the support shell. that we already pre-drilled earlier. Okay, that's good. We're going to screw the support shell into the baseboard. Again, this is going to prevent the support shell from floating up and away from our model.
Hey Milo, do you think you need to put any mold straps or clamps or anything on that before you pour?
The question is, do we put any mold straps or clamps onto the mold before we pour? That is a good backup. That is definitely something that is going to be helpful. Is it recommended? It depends on how big the mold is. If you're pouring something that's, 10, 15 inches tall, then that's really overkill. I mean, overkill. If you're creating something that's taller, where you're going to be using a lot more material, then a mold strap will be recommended. You can either use mold straps, you can use a bungee cord, but something that's going to hold these two halves together that you can put over and then tighten up and put some pressure. That way these two halves won't try to pull apart from each other due to the pressure that's created inside the mold. So our mold here is pretty much ready to go. There's one thing that I like to do. I mentioned rolling the Sculptex soft in these snakes. And what I like to do is go around the perimeter of the mold and squeeze that firmly down. This is added security, added safety, so that the silicone does not escape out of the mold cavity that we've built up. And I'm going to do that all the way around. And then we're going to do the same procedure on the sides here where we apply the hot melt glue. Is this too much? Yeah, possibly, but it's an added safety, added security, knowing that this won't leak. This is all going to be scraped off later, so not a big deal. All right, we're almost ready.
This is important to do because, as somebody mentioned on here, silicone will flow through the tiniest little pinhole in the mold box or in the edges of a piece.
My grandfather had a saying about water that will find its way through the tiniest cracks, and it will. The liquids are, even though they might be thick, they will find their way to seep through little cracks. The worst case scenario is you don't do something like this where you back up your work and you pour the mold and walk away from it. You come back the next day to find out that all the silicone that you poured has escaped the mold and is now a flat mold of your floor. So a little bit extra work at this point will prevent big headaches down the line. So a little bit extra safety pays off. Same thing with the double mixing technique. When you mix silicone, it's a really cheap insurance to make sure that you're doing a good job between the mixing of the two components. So, and here is what that setup should look like. Move some of my tools out of the way so you guys can see. We have the seam lines clayed up with the Sculptex oil-based clay all the way around. We put a couple of screws at the edges here to hold the mold in onto the surface itself. The mold itself is pretty much ready to go. We're ready to pour silicone into here. One thing you want to do is keep an eye and understand where you have pour spouts, where you have weeping holes, or I guess you can call these air vents, so that when you're filling up the mold, you can go around and plug those up as they start to leak material. And while saying that leaking material sounds bad, it's actually what we're aiming for. We want to see the material coming out of the mold in those areas. So we're going to put this aside, and we're going to focus on prepping our material. I think it's this way. A, B. That's right, B stands for blue. So we got our product already dispensed. This is Mold Star 30. We pre-dispensed the material. The platinum silicone is not that sensitive to moisture, to the air, so it's okay if I dispense this a little bit ahead of needing the product. Now, I will be mixing this in a cut up 5-gallon bucket. The reason for that is I'm mixing a bit more material than would fit into one of these clear buckets. And rather than restricting myself from not being able to mix thoroughly, I'm choosing to use a little bit larger container that's going to allow me to mix the material better than it would be in a smaller container. I'll put some gloves on. And again, we're using the Mold Star 30 here for several reasons. Of course, the viscosity, very important. The material durometer, 30 durometer, also important to me for the stiffness of the mold that I am looking for. And it is a 1-to-1 mix ratio by volume. We have plenty of work time. The pot life of work time, I believe, is 15 minutes with a cure of about 4 to 6 hours. Don't know that exactly on top of my head. But always take a look at the technical bulletin, understand the material that you're working with so that you can process the material better. You don't want to mix a lot of material up only to find out 6 minutes into the pot life that the product has a 6-minute work time. Would render it useless if you're still mixing. So we can go ahead now and dispense the part A into the mixing container. And then we're gonna dispense the second here. 2 containers that we make pre-dispensed. And one thing I forgot to mention is the estimate. How can you estimate how much product you're going to need for a project like this? One thing you can do is take the clay that you removed out of that cavity, weigh that out, and it'll give you approximately the quantity of product that you're going to need. Now, my recommendation is always to have a little bit extra on hand in case you made a miscalculation and you just need a little bit of material to top off the mold. It's better to have it on hand than having to wait for the material to arrive in the mail or having to go to a store to purchase more product. So don't buy too much material, don't have too much material on hand if you can't use it, but a little bit extra product is definitely a wise choice and a good recommendation. Now we're going to scrape the sides, scrape the bottom off the mixing container. Scrape the sides. It's kind of nice working on a larger container. It makes it a lot easier to prep the material. I reverse the sides and then go the other way, scraping the sides, scrape the bottom, scrape the side, scrape the bottom. Really important. That's where the unmixed material is going to cling to the sides and the bottom of the container. So that's what the area that you want to focus on. And then once you mix the product together and you have a good mix, you want to take a secondary clean mixing container that we're already prepped here. Make sure there's no dust. And then we're going to transfer the material that we mixed into the second mixing container. Again, this will be a double mix technique. That's what it's called. And what I like about this technique is that it shows you that everything that was at the bottom of your mixing container is now at the top. And you get a better idea as far as did you mix thoroughly the first time around. If you see streaks at the bottom of the mixing container of one or the other material, that means you didn't do a good job of combining them. And this is actually a good procedure that you chose to do. Remember, it's not about how long you mix the material for, but how thoroughly you mix it for. Again, scrape the sides, scrape the bottom. Now, you could potentially vacuum degas the material if you need to. But we went out of our way to choose a product that's very viscous, that's going to flow easily, and I'm not too worried about the air bubbles in the material that we mixed in. Those are going to rise to the surface and pop basically on their own. Now we have our material ready, we have our mold ready, we have a lump of Sculptex oil-based clay ready. Make a couple of strings here, very good. And then we can focus on pouring the silicone into our cavity. Now you can see how that wide opening works well for pouring a large quantity of material very fast. And because the silicone is viscous and flows well, you don't have to stop and try to get the material in there. It just flows into the mold quite nicely. I'll take a break here for a second. And why? It's because I can see the silicone coming out at the bottom here. See that? It's weeping out of the holes. We're going to plug those up with some Sculptex. And as I pressed on that one, a huge air bubble came out over here. So we're going to let that de-air for a second, plug out some other holes. And on the back as well, a couple of weeping holes we're going to plug there. Now, don't worry about the mess that the silicone makes on the support shell. That's going to be easily peeled off and won't matter to the performance of the mold itself. I'll come back to this one here as well and plug that up. All right. Everything good, that's blocked, good. We can continue pouring the rest of the material or till the next vent hole. I'm going to stop here again. There's a couple of weeping holes I want to plug up. Whoa, whoa, this guy's gushing out. And in the back here as well. Now, one thing I see here is that we are at or beyond the halfway mark here. And what that tells me, perfect. I have the same. Remember we drilled a hole here in the front? That was in that difficult area that I was worried about. I'm going to plug that up as well. And now, knowing that there's a difficult area here in the middle somewhere, I'm going to just tilt the mold a little bit back and forth to help and dislodge that air bubble that might be trapped. I don't know if there's an air bubble there, but this is a preventative measure that I like to do to kind of get rid of any possibilities of air trapment in that area. Now, not every mold will require this kind of application, this action, but I like to add it because I know that area has a little bit of an undercut. And now we can go ahead and pour the rest of that material. I'm not 100% sure that we mixed up enough material. Oh, we did. A little bit of an air bubble there popped. No problem. I'm just going to top that off. And there it is. Now, if there's any kind of air bubbles coming to the top at this point, that's actually a good sign. That means any air bubbles that were trapped here are making their way up and out of your mold. You want to kind of stay with the mold for a little while. Make sure there's no leaks around the perimeter anywhere where you can see material coming out with no stopping. The one reason why I like to stay with the mold right now is if this level sinks too much, you don't want it to expose the model. Again, if there's a large air bubble that's dislodged and traveled up, it'll create the need for the material down below and suck some of the material from the top here down. So a little bit extra up top here. Just going to use some of that extra material that's left over. That's good. So not a lot of material left over in the bucket, which is a good sign. I like that. Not a lot of waste was created. I'm going to just check over this one more time. This doesn't matter up top, that we can peel off later anyways, no problem. This is all fine. This is just a drip, I believe. No, there's a... that's a drip. One thing that I didn't do that is recommended is you can circle the air vents that you created. That way you get a visual where you actually put a hole and you don't have to guess in case you drip some material as I did here. But this is pretty much it. The material is now allowed to fully cure at room temperature and just left alone. Now, one thing to keep in mind is when you go back to open that mold, there will be a lot of suction because you poured a liquid rubber into two rigid cells and it filled all the cracks and crevices, And the material itself, now to open that up is going to require, again, a little bit of slow stepping. So when you go to open the support shell, remember to go slow, don't rush into it. Just pry it slowly open until the shell itself, the support shell, starts to give and starts to separate on its own. All right, we're going to move this aside, and then I'm going to show you guys a final casting, basically, on what the mold will look inside like when you're finished with it. So last night I did a casting so you guys can actually see what that mold then produces. So here's our open mold. I already cut this apart a couple days ago. Here's our second side of the support shell, and here's the actual casting. I left this halfway in the rubber mold just so I can peel it away in front of you guys. But just in a short here, I want to show you. This is what the mold is going to look like when it comes out of that cavity, out of the support shell. I then went ahead and cut the mold open along the sides and then in the middle between the legs and the arms. If you can zoom on that, please. I want to show you some of the cuts. So right here along the edges, you can see there's a positive, like a little bump. That is a channel that was cut with a mold knife. So we went along the perimeter and cut a channel all the way so that the two halves of the mold now register perfectly into each other. There's a positive here, there's a negative on the other side of that mold. You can see that these cuts here between the legs are quite jagged and rigid, and that actually allows for that mold to find the other half, its partner, perfectly. These edges, these ridges are going to align perfectly in the other half of the support shell. Now, the area here where I was worried about air bubbles getting trapped, that transferred quite well. There's no air bubbles left in there. I'm very happy. And overall, the mold itself doesn't show any signs of air bubble trapment. Now, one thing I do want to point out with this technique, when you do go to slice the mold open, you can potentially slice the mold open only on one side so that the other half stays attached and you don't have a seam line on the other half. That's a possibility. It really comes down to the mold maker, his preference, his needs, the end result that you're aiming for, basically. When you do cut the mold open completely, you do expose your other side of this casting to a seam line that you potentially have to cut or finish off on the final casting. Now, because this is made out of one single piece of rubber, the two halves find their other half perfectly together and fit perfectly back, so that you'll see on this casting here, as we demold it, the seam line is virtually non-existing. I think this goes into the other side. Put this back. And one thing I wanted to point out, these keys now that we created in the mold fit perfectly back into the support shell and hold the rubber in the support shell firmly. So when you go to put this back together, you're going to press the mold into the support shell, and if something doesn't fit quite right, you'll feel it. It'll stick out. There will be a bump, and you'll know that that mold is not sitting perfectly. Again, that's what gives us a really good final casting, minimizing any kind of finishing seam lines, flashing on the castings, and so forth. And you can see that that mold will not fall out of the support shell due to the keys that are built into the mold. So that's a quite nice feature there. Once you have it in there, it should stay in there nice and firm and ready to be closed for the next casting. Here's our final casting. Like I said, I didn't remove this completely. One more thing I want to point out right here. Can we see that? You guys see my finger going through there? So when I was cutting the mold open, the knife traveled a little bit too close to the edge and actually went through the mold there. Now, I'm not too worried about it because it doesn't actually, it's not touching the model. It's not touching the actual model. Material doesn't seep out of there. So this here, while it looks kind of ugly, it's actually just a visual defect. The mold itself works perfectly. On the other side of that mold, I actually ended up cutting a slice through and had to fix it. And if you do need to fix rips or cuts that you put into these molds, you can use the, help me out with the name, what's the, Silpoxy, thank you. You can use Silpoxy to fix silicone or tin-based silicone molds that you potentially ripped or cut into. So let's just go ahead and remove the silicone from the rest of this casting. You can see that it still is very tight to the model. Slowly get that out. All right. Now, if you take a look at the side here, we do a close-up, you can see a little bit here at the bottom. There's a little bit of flashing here. That's easy to clean up. Even with my fingernail, I can scrape that off. But then there's no flashing here at all. You can see a seam line very faintly, but the casting itself is really nice. There's not a sharp seam line. There's a little air bubble here that I'm going to have to fix, but that's very minor. Overall, the casting is a success and can be actually post-finish and used. And just to show you guys that difficult area that Jason was talking about earlier, so by using the mold correctly, I was able to get away and get a good casting with no air bubble stuck in the fingers there where there was a difficult area, as you saw on the first casting that I got out of that mold as well. So a little bit understanding of the casting process, the way that your mold is set up, is very helpful. And of course, the first time that you do a casting inside the mold, it's not going to be 100%. You're going to learn a lot from it. And I consider it a cleaning or test casting for that particular mold.
Milo, speaking of casting, is that Smoothcast 300?
No, this is actually, the question is this Smoothcast 300? This is actually Dual Matrix Neo. So I wanted to show you guys that you can use the Dual Matrix Neo for a support shell material as well as for castings, and replaces a lot of plaster-based castings that you can make.
And that brings up a point because Neo will bond to Neo. So before you put your mold, rubber mold into your support shell, it might be helpful to put a little bit of release in there too.
That is
in case you have some leakage.
That is absolutely correct. And it's one of those points that I kind of skipped right over, like a stone over a lake. I don't skip that well. But before you close up your mold is a good thing to actually take the support shell and apply some sonite wax to the inside of the support shell, especially around these edges here. This is where the mold comes together, and if you're going to see leaks anywhere, it's going to be along the edges here. And if the material leaks out, you can get a bonding, but I have a little ace up my sleeve. Remember, we cleaned this out with these isopropyl alcohol, and clay was on there. So most likely the material won't stick into this, but it will stick to the sides if there's no release present. So it is a good procedure that you should do when casting alike materials. So if you have a support shell made out of the Neo and you're casting Neo, it's a good habit to put the release on the flange here at the bottom, so there's nothing that sticks to that, as well as the inside of the mold. So I'm just going to put this back together, and as you noticed, I put also some drilled holes into the support shell. Find your home, there we go. So again, we have some holes that we drilled into the sides. That way we can clamp the mold together and push it together tighter to, again, make sure that there is no material that leaks out. But very good point. Release agents are your friend as long as you understand how to use them and also how to remove them in case you have to for painting purposes or such. So that brings us pretty much to the end of our presentation. Let's just take a quick look at what we talked about today, what we learned today. We talked about the advantages of making cavity pour molds versus other mold making methods. We analyzed our model that we worked on. We talked about choosing materials for the mold and the support shell, the determining of separation lines and how to deal with them ahead of time by building up the proper mass for them. We talked about claying up models and some clays, how to place air vents, pour spouts, the flow channels and the keys, and basically showed you a step-by-step of material application to create a support shell and the mold itself. Now, the materials we use today is the Moldstar 30. That's the blue silicone we used. That's a platinum silicone. The Duo Matrix Neo we used for the support shell, as well as some of the additives like the Matrix Accelerator, Matrix Thickener, chopped glass, and the Sonite wax for release. So I want to thank you guys for watching and participating today. And don't forget that we will be announcing upcoming live demos on social media networks, in our email newsletter, and of course on our YouTube channel. So don't forget to subscribe, sign up, follow us, and if you have an idea about what we should do next, please let us know down in the comments below, and make sure you give us a thumbs up button. Now, once again, thanks a lot for joining us, and we'll see you at the next presentation. Ciao.